All right, this is a 4th grade lesson on prime numbers. So have any of you heard of prime numbers before?
Yeah, I think so.
Yeah, maybe?
Yeah.
All right, well, it's all right if you haven't. By the end of today, you will know all about prime numbers. So what a prime number is, we've already talked about factors last week. And so a prime number is any factor, or any number that has only factors of 1 in itself. And it has to be greater than 1 as well, because 1 is a very special number in math, and it has a lot of different qualities about it. So yeah, so that's what the definition of a prime number is. Now, let's just start by looking at the number 12. Let's think of some of the factors of 12. I know that 3 times 4 equals 12, so that means that 3 and 4 are factors of 12. Can anyone tell me any other factors of 12?
2 and 6.
Good job. Yes, 2 times 6 equals 12, so that means 2 and 6 are factors of 12. Now there's one more that's a little tricky. Sometimes you don't always think of it this way, but there's actually 2 more factors of 12. Does anyone know them? No? That's okay. 1 times 12 is 12. That's actually a really easy one, but sometimes you forget about those. Okay, so we know that 1, 12, 2, 6, 3, and 4 are all factors of 12. Okay, now let's look at the number 5. Can you think of any factors of 5?
1 and 5.
Very good, Liz. 1 times 5 equals 5, so 1 and 5 are factors of 5. Are there any others?
No.
There are not. Since 1 and 5, which is 1 and the number itself, are the only factors of 5, that makes 5 a prime number. Okay, so we know 5 is a prime number. And when a number isn't prime, it's actually called a composite number. So we have 12 as a composite number and 5 as a prime number. Okay, now what we're going to do is we're going to use these number lines that I gave you. And we're going to use, but what I want you to do is listen very carefully to my instructions before you start marking them, because it's really important that we don't rush ahead. Now, what we're going to do is, a long time ago, a Greek mathematician and philosopher called Eratosthenes created a system to find all of the prime numbers. Now what he did was he created something called the sieve of Eratosthenes. And what a sieve is kind of the same as a sifter or a strainer when you go home and you make macaroni and cheese and water runs through the bottom and all that's left is the macaroni on the top. That's what we're going to be doing with our prime numbers here. But what we're going to do is we're going to sift through all of our numbers, and all of the composite numbers are going to be crossed out on our paper, and all that's going to be left are those prime numbers. So we're going to start by shading in number 1, because we know that number 1 is not a prime number, just based on the definition. So go ahead and shade that number in. Now we're going to move on to number 2. Is number 2 prime or composite? Let's think about the factors of 2. The only factors of 2 are 2 in itself, so that means that it's a prime number. Go ahead and circle that prime number right there. Give it a big circle because we know it's prime. Oh, Leslie, I think I noticed you shaded it instead, so why don't you go ahead and erase that? That's okay. We're using pencils, so it's okay to make mistakes. We can just go ahead and change that. Okay, so now what we're going to do, since we know that 2 is a prime number, that also means that all the multiples of 2 are going to not be prime, because we know then that they can be divided by 2. Do you understand? So let's say if we look at 4, we know 4 can be divided by 2 because it's an even number and it's a multiple of 2. So we're going to go ahead and shade in all of those even numbers that are multiples of 2. So we know that 4, 6, 8, 10, 12, those are all multiples of 2. Go ahead and shade in all of those multiples. Let me know if you start to see a pattern going on your papers.
Every other.
It's every other, yeah. Oh, I see John is kind of scribbling all the way down the row. He noticed that it's just straight bars all the way down the chart. Kind of looks like a jail cell or something like that once you get them all shaded in, because they're straight bars. Yeah.
I have a question.
Yeah, what's your question?
If number 1 isn't a composite number and it's not a prime number, what is number 1?
Well, that's a very good question. And you know what? For extra credit, if you go home, you can do some research on your own. Well, or just for fun, if you guys want to try to find this out. And you can tell me why you think 1 is not prime or composite. So it's kind of it's some hard work there. And you know, by the end of the week, we can actually talk about it all together, but if anyone can figure it out on their own, that would be great. If anyone wants to work above and beyond. Okay, so let's look at number 3 now. Is 3 prime or is it composite? Anyone can answer.
Prime.
I think it's prime. Yeah, all right, you're correct. It's prime. Now what we're going to do is find all those multiples of 3 and then shade them in, because we know if it's a multiple of 3, then it can be divided by 3. So let's think about those.
6, 9.
3, 6, 9, yeah.
12.
15.
18. 21.
Good job.
27. 33.
You guys are doing a very good job. And you're pretty much doing it all on your own right now. You're doing great. Okay, and remember, if you make a mistake, it's okay because we're using pencils to erase. Okay, let's move on to we have already shaded out number 4, so we don't need to do that one. Now what I want you guys to do as a group we're going to divide into groups of 3, and I want you to try to finish the board using this pattern. So we're going to move on to 5 and then cross out all the multiples of 5. Because we know that 5 is prime. We did that one on the board together. So you can circle that one. And then you're going to shade in all those multiples of 5. And together you guys can work together now. So if you need some help, you can ask your neighbor. Okay, keep working and try to fill out the whole board. And you might notice that there's actually fewer and fewer numbers that are left at this point. So go ahead and try to move all the way through all the numbers on your chart of 1 through 50.
Okay, so what do we have, 7? We already did 7? Prime. So let's see, 7. What about 11?
How are you doing over here, Liz?
Oh, 9. That one we already did as a
Okay.
3.
You trying to figure out some of the multiples of 7? Well, why don't you see if John can help you think of some of those multiples of 7?
14, 21, 28, 35. I think they're all used up.
So, okay, if they're all used up, go ahead and move on to the next number.
Next, we got
11.
Okay. And then that's,
22.
all those are used up.
33.
13, let's see.
44.
13. So that one's prime, right?
9.
9. It's kind of just the ones that are left now, right?
Yeah, it's getting a lot easier to find those prime numbers because we've already crossed out a lot of them.
So once you get to 29, we're pretty much finished, right?
37.
I don't know, you should ask your
Because it only goes up to 50.
Well, yeah, but we're just still looking at them. Yeah, it looks like all, oh wait a minute, what about 49?
Now, if you think about it, anything to find the next lowest number, multiple of it, you'd have to multiply it by 2. And so once we get to 47 or 49, if you multiply that by 2, it's going to be much higher than what's left on the board. So you're probably right.
What about 49? Is that one's divisible, right?
By 3?
By 7. Is it?
Oh, you might have missed it then if you were doing your
Yeah, because I don't
if you're doing
think
your
we got that
multiples
one.
of 7. Yeah, it looks like you might have forgotten one.
14, 21,
Because what's the
28, 35, 42, and 49. Because if we keep adding 7,
Right.
That's a good observation, John. I'm glad you caught that one.
I almost missed that.
All right, so it looks like you guys have all finished. I'm going to put this down again. All right, so now since we have a couple minutes left, what we're going to use, or what we're going to use these for, is if you ever need to figure out if a number is prime ever again in the future, you can just pull this right out of your desk and just look at it. And we're also going to try to remember these prime numbers in the future. Does anyone know why it would be important to remember a prime number in life? Like, what's the point of even learning about prime numbers? Because I'm going to tell you, every single one of our standards of learning there's actually a point for these standards that we have to learn. So what do you think the point is of learning about prime numbers? Can anyone think of anything? Think about if you're going to a grocery store or if you're baking cookies. Let's do that. Let's say you're baking some cookies. Would you want to bake a batch of 11 cookies or 13 cookies or any prime numbers? Or would you rather have 12 cookies so that you can divide it amongst more groups of friends? Do you understand what I'm saying? Like, let's say you were going to a grocery store. You don't always see boxes of cookies in 11. You don't see batches of cookies being sold by number 11 because then you'd only be able to share it with either 11 friends or one friend. But if you have a box of 12 cookies, like you might see a lot of times, you could give it to 3 friends evenly, 4 friends evenly, 2, 6, 1, or 12 friends all evenly. And you could share it so you wouldn't have to split it up and have to cut cookies in half and things like that. So that's just one time you might want to avoid those prime numbers because sometimes they just make it a little bit harder to divide things. That's just one example. And you know what? Next time you go to the grocery store, see if you find any prime numbers being used. You might see things being sold in 2s because then that's just a nice small number. But those bigger numbers, you're going to probably find fewer and fewer prime numbers being used.
So, question.
Yeah.
Are all prime numbers except number 2 odd numbers?
That's a good question too. I like your questions today, Liz. Can anyone answer that? Does anyone think they know? John?
Yes, because all the even numbers are divisible by 2.
Exactly, yeah. Remember when we shaded out all those multiples of 2? The very first time? That was because if anything is even, it can be divided by 2. So we know that it can be divided by more than just one in itself. All right. If you need help after class, just feel free to come by. Okay, so now really quickly, since we have a couple seconds left, we're going to play a quick game and we're going to use our cards. It's called Buzz. Now what happens in this game is we're going to go in a circle and say the numbers in order. But if it's a prime number, you have to say Buzz instead of saying that number. So for example, if Leslie starts, she would say 1. Then John would say, instead of 2, he would say Buzz.
Buzz.
And then Liz would say
Buzz.
Buzz. And then I would say 4. Leslie, what would be the next one?
Buzz.
6.
Buzz.
8.
9.
10.
Buzz.
12.
Buzz.
14.
15.
Good, so you guys kind of got the hang of it. And it's a little tricky because this is a game where you really have to listen to each other and pay attention to which number we've moved on to.
Okay.
So we're going to play this again tomorrow, but just make sure you go home tonight and study those prime numbers so that when you come back tomorrow, you won't make any mistakes in the game. All right, thanks. Bye.